Assalamualaikum and hi. So this is chapter 6, application of vectors in geometry. So let's see what we have in this chapter. So basically we have two subtopics, which are, the first one is lines in space and the second one is plane, sata. Line is garis and plane is sata. Okay, so the first one is lines in space. So basically this is what you have when you have the application for vectors. This is what we call as this straight line. This straight line over here is a line, okay, or we can call it as a normal to the plane. This is your plane. Satah kamu, okay? Yang 4 segi ni, this is the plane. So this red line over here will be your normal to the plane. The normal to the plane is always 90 degrees. Dia selalunya 90 darjah dengan kamu punya sata. And if you have any point somewhere around here on your sata, on your plane, here, let's say this is a point and this is a normal to the plane. So this is what you need to know regarding the application of vectors in geometry. Okay, now we move on to the expressing the line in space. Okay, there are three ways of expressing the line in space. Ada tiga cara macam mana kita tunjukkan line tu di space lah, di ruangan. Okay, satu adalah using vector equation of the line, and the second one will be the parametric equation of the line, and the third one will be Cartesian equation of the line. So we have these three types of equation in order for you to express the line in space. Okay, let's go one by one. The first one is vector equation. So what is vector equation? Okay, suppose we have position vector r, that is OR. So once you see position vector r, that means the vector is start from the original O, or the origin O to the R, like this, OR. And we have X, Y, and Z. E is a point which is free to move on a line. So we have another one, position vector A is given by OA. Okay. So, and we have V over here. V equal to AI plus BJ plus CK is a direction vector of the line. So we have altogether three types of vectors. The first one is OR, OA, and the V one over here. So you have position vector R, position vector A, and also direction vector, which is V. Okay. So for vector equation, you can write it down using this formula. R, vector of R, position vector R equal to position vector A plus T V. V is your direction vector over here. So you just need to memorize this formula, R equal to A plus TV. So what is R? Then R, you go back to the position vector of R, which is this one. You can write it down using this, xi plus yj plus zk equal to your A vector, position vector A, given by this. So you just substitute the value of the position vector A. So you have x1i plus y1j plus z1k. And then you plus with t. T is just t over there. And then v is your direction vector. So whatever you have here, you can just put it inside here. So this is your vector equation. Okay, this is a vector equation. Let's see the first example. This is a line L passes through point 1, -4, and 2, and is parallel to 2i minus j plus 3k. Now you need to find the vector equation for this one. So you are given a point over here, A, and also which is this line is parallel to this. Okay, so how do you find vector equation? First of all, we know that vector equation is this formula, given by this formula, r equal to a plus tv. Now you already have your a, which is position vector of a over here. And you need to find the v, direction vector. So the direction vector is given by this. So you need to substitute it into the formula, this one. Put it inside here. Then this is your vector equation. Okay, so this r you don't have to substitute, okay, because r is actually what your vector equation is. So r equal to these vectors. Okay, after you just substitute the value of position vector a and direction vector, this is v. Okay, so we move on to the next example. Find a vector equation for the line through the point, this one, A and B. So you have 2 points over here, position vector A and also position vector B. So of course you need to find the vector equation using the formula given just now. So this step 1, choose a position vector A or B. You need to choose one. Okay, you either A or B. So we choose this one, you choose A. Okay, position vector A, 3i plus 4j minus 7. Okay, 3i minus 4j plus 4j minus 7k plus t. And you need to find your v over here. We don't have to use both A and B, but we're gonna need this B to find our direction vector. Okay, so we need to find v, of course, using this formula, r equal to a plus tv. Okay, v is actually given by this one. Okay, you need to find v is actually given by vector ab. It is position vector, right? So it is given by a to b, but we don't have this vector ab. So what you need to do is that, since we don't have vector ab yet, so but you have these two, OA, which is given by this, and OB, given by this. Okay, so from this OA and OB, of course, you can find your your AB. Okay, so AB is given by this, AB given by negative OA plus OB. Okay, so what you have over here, you just substitute the value. You have OA is given by this one. This is OA. Okay, let me jot down a little bit. This is vector OA. And this is OB. So you have these two. Now you can find the AB vector. Okay, so after you substitute the OA and OB, then you get the AB over here, vector AB. Vector AB is actually your position vector. So you just need to substitute this into this. Okay. Then you have your R equal to, just write it down back, this one, plus TV. What is your V just now? Your V is AB, vector AB, which is this one. Okay, so you just write it down. So that is the vector equation. Okay, the second equation that we're going to see is parametric equation. So how do we obtain parametric equation? Is by equating the coefficient of I, j, and k of the two sides of equations. So you have this left-hand side, and this is right-hand side. You're going to equating, samakan the coefficient or the perkali of I, J, and K. Okay, let's see. For I, let's see, the first one is the coefficient for I. Okay, you have I over here, I over here, and I over here. So you're going to compare or equating, samakan dia punya coefficient, dia punya perkali. Okay, so the coefficient of I on this left hand side is actually equal to X. Okay, so you have X over here. Then equal to, because this is the only one for I kan, on the left hand side, so you write equal to. Then we see on the right hand side, you have the coefficient for I over here is X1. So you have X1 plus T, since you have T over here, T, and then you have the coefficient for I is A. So that's why you have A over here. So that is you are equating the coefficient of I. Now we move on to J and K. But before that, I'm sure you all of you might want to ask, where does this equation come from? This actually in the box is actually the equation from the vector equation, R equal to A plus T V. Okay, like the one you have learned in the vector equation. Okay, so this is actually R, A, and T V. Okay, next we're going to equating the J, coefficient for J. So in left hand side you have Y. So you have Y over here, and on the right hand side you have Y1. That's it. You have Y1 over here plus TB. Because this is J, right? So you have B. And it's the procedure is the same for K. So coefficient for K is Z equal to Z1 and plus TC. So these are all your parametric equations. Okay, so you just need to write down in these three equations over here. X equal to x1 plus TA, y equal to y1 plus tb, and z equal to z1 plus tc. So this is how you obtain your parametric equations. Okay, now we move on to the example. Okay, given equation line L. So you have this equation R equal to, this is your A, T, and V, right? Find the parametric equation. So you need to find the parametric equation. But before that, all you have on the left hand side is R. So you need to elaborate ataupun leraikan dia. So it's actually like this. The parametric equation will be like this. So what happened is that yang dekat sini saya dah leraikan dia. Maksudnya you dah expand dia. Okay, so R ni, this R is actually equal to this xi plus yj plus zk. So that is actually R. And for I, okay, dekat sini if you can see, dia dah factorize. Untuk I, dia letak dalam satu bracket. Untuk J, dia dah kumpulkan dalam satu bracket, and for K dia dah kumpulkan satu bracket. So how does they obtain this one? It's actually what you have over here, the original one. You kembangkan, you buka bracket this one, you buka bracket ni kan. So you have 2 TI, TJ plus TK, and so on so forth. So bila you dah kembangkan, you susunkan yang I, all the I. Okay, you kumpulkan on this side. And then we go to the J and then K. Okay, now you have to factorize dia. Kumpulkan dia dalam satu tempat lah. For I, 1 plus 2T, I. Letakkan I tu dekat luar. Factorkan dia. So you have this one. So this is your parametric equation. Okay. It's either you write down in this form or you can also write it down in this form. Macam yang ni tadi. Okay. So dua-dua boleh. Okay. So kita tengok xi untuk x ni berkali untuk I sebelah sini adalah x. Berkali untuk I untuk on your right hand side adalah this one. This is the coefficient. So for J, the coefficient is y on the left hand side, and on the right hand side the coefficient is this one. And then for k, you have on left hand side the coefficient is z, and on the right hand side you have 2 minus 3k. So now you can equating lah, samakan dia, compare sebelah kiri dan sebelah kanan. So that's it, your parametric equations. See, after you obtain this one, you can write it down. X equal to 1 plus 2t, y equal to negative 4t, and z equal to 2 minus 3t. So this is your final parametric equation. So all these three parametric equations, you have three actually. You have three terms. Satu in term untuk x, y, and z. Sama macam yang ni tadi. So it's actually the same. Okay, you have untuk x, untuk y, and untuk z. You have three parametric equations. Okay, let's move on to the third equation, which is the last one. We have covered vector equation and parametric equations. Now we want to see Cartesian equation. Cartesian. So you have this one. Previously we have obtained our parametric equation. So this t, all you can see you have t, and t. This t is actually equal to x minus x1 over a. How do we obtain this t? It's actually macam ni, yang sebelah sini kan you bawa pindah lah, x ni, x1 ni bawa ke sebelah sini. So you have like x minus x1, then ta ni boleh bawa ke sebelah. Bila bawa ke sebelah, dia divide by a. So yang tinggal di sebelah cuma t. Okay, that's why you get this one. Sebab itulah you dapat yang ini, t equal to x minus x1 over a. So sama juga lah untuk this thing, untuk y and z. So you have like this, meaning that you are eliminating t from parametric equation. Eliminating mean you remove dia. You keluarkan t tu daripada parametric equation. All you have is this, kan? Three parametric equation. So for the Cartesian, you want to remove, you want to eliminate, hapuskan, atau keluarkan this t. So it goes the same for y, which is kita keluarkan y, ni bawa pindah ke sebelah sini, so it's become y minus y1. Then that b bila bawa ke sebelah, they become divide by b. So that is actually equal to t. And it's the same for z. This z1, you bring it on this side, you get z minus z1. And this c bila bawa ke sebelah, it become divide, kan? So you divide by c. Okay. So this is how you obtain your Cartesian equation. So we have note over there. The coordinate of point A, x1, y1, z1 is the numerator, and that the component of v, vector v, is the denominator, dia kata. Okay. So this is how you obtain the Cartesian equation. So kalau ingat, untuk senang ingat, vector equation yang simple. Vector equation is R equal to A plus TV. And then the parametric equation, you have three equation like this. Parametric equation, 3 sebutan. And for Cartesian equation, you remove T. Dia bentuk dalam pecahan macam ni. Semua ini Cartesian. Kalau ada bentuk pecahan per semua ni, that one is Cartesian. Okay. So let's see the example for Cartesian equations. Given parametric equation line L, which is this one, we have three parametric kan equation. Kalau parametric je, dia mesti 3, or sometimes it can be 2 because they don't have k over here. So x, y, and z. Find the Cartesian equation. So you kena cari. Remember how do we obtain Cartesian equation? Is by eliminating or removing the t. Okay. Singkirkan that t. So kita bawa pindah x. This one bila you bawa pindah ke sebelah, it become minus x minus 1. And this 2 bila you bawa ke sebelah, it become divide. So this is for the x. And then we move on for y. This one. bila you pindahkan, you want the single t over here, t ni pula yang bawa ke sebelah. So y ni you akan bawa ke sebelah sini, negative y minus 4 divided by 1. And for z like this. Okay, so you want just t over here. So you have your t for each of x, y, and z. Now you're going to equate thing there. Samakan dia. T is actually equal to x minus 1, blah, blah, blah. Combine dia, gabungkan dia lah. Equal, equal, equal. So this is your Cartesian equations. Easy, right? It's easy peasy. Let's see the next example. Example 5. A line passes through the points 1, 3, and 2, 5 on the plane. Transform the vector equation of the straight line r and blah 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 into the Cartesian equation of the line. So you have 2 points over here, and dia kata you need to transform the vector equation, which is this one is vector equation, right? Tengok, dia kata this one is vector equation of the line. This is r equal to a plus t v. So yang dalam bracket tu actually your v into the Cartesian equation. So what happened next is Cartesian equation y equal to mx plus c. So you have like this, xi plus yj equal to I. This is actually this, okay? R equal to a plus tv. It just, can you spot what is the difference between the previous, this equation and the previous one you have seen before? Okay, you can notice that there is no k. Tidak ada sebutan k dekat sini. Dia cuma ada ij sahaja. Kalau sebelum ni you have I, j and k kan? But this one you don't have. You just have 2. Okay, hanya 2 sahaja. I and j. Okay, I and j. Okay, so you have r equal to a plus tv. This is r, this is a, and this is v. So what happened next is you're going to extract this one. Kita obtain dahulu you punya what we call that parametric equation. Sebab this one adalah vector equation. Daripada vector we want to find the Cartesian. But you miss out in the middle, you need to find the parametric. So macam mana cari parametric? Kita equating. Kita samakan yang sebelah kiri dengan sebelah kanan. So untuk sebutan x, untuk the coefficient for I, you have coefficient for I is actually x equal to 1. This is 1 kan? Berkali dia 1 dekat sini. 1 plus t. T kali I, this dah dia punya. And then you have t is actually equal to x minus 1. This is the parametric, okay? This is parametric. This is parametric. Parametric equation. Now you are eliminating the t. This is the Cartesian. We want to eliminate the t. Okay, so sama juga. That one untuk x, untuk sebutan I. We go to the j. Untuk sebutan j pula this one kan? This one. So you have on the left hand side you have y. On the right hand side you have 3 and 2t. You have 2t lah. Jangan lupa multiply with the t over here. Okay. So you have this one. Y equal to 2t. So bila kita eliminate the t, keluarkan t tu. So you susun semula y minus 3 divided by 2. So you can now obtain your Cartesian equation. And this one. So you samakan lah. T is actually equal to x minus 1 equal to y minus 3 over 2. That's it. Either you write it on this form or this form. So the Cartesian equation line is actually y equal to 2x plus 1. Macam mana pula dapat yang ni? Ni you susun semula lah. Daripada sini you susun bawa naik ke atas. 2 ni bawa naik ke sini dia jadi 2x. And then ni darab ni jadi negative 2. Negative 2 nanti tambah 3, dia jadi 1. You susun semula. This one, you susun semula. Rearrange dia sampai you dapat ni. Kenapa dalam yang ni? Because this one is actually this. Dia mau dalam bentuk y equal to mx plus c. Cartesian equation line. Kalau Cartesian equation sahaja, this one. This one is enough. But dia kata line dalam bentuk line, so you have to change it into y equal to mx plus c. Okay, the next example is show that you have this one point over here, 7, negative 1, and 1. So you have I, J, and K. I, J, and K lies on the line R and blah blah blah. So this is actually vector equation. This is vector equation, okay? Ni vector equation, remember? Macam mana saya tahu dia vector equation? Because it start with R and it has T inside. Sorry. So you have R, A plus T, and you have in the bracket is your V, kan? That's why I notice. That's how I recognize my vector equation. It start with R. Okay, so show that this one lies on the line this one. Maksudnya, you kena buktikan, you kena tunjukkan point A ni, dia terletak dalam line yang ini. So, what happen is that, kita leraikan ini menjadi yang ini. R, remember, untuk R, dia adalah xi plus yj plus zk. So, this whole thing on the right hand side, you just rewrite it. Okay, tulis semula. So, now you have to obtain the what we call parametric equation. Equating, samakan dia, parametric equation. This is parametric equation. Macam mana cari parametric tadi? You equating the left hand side, the coefficient on the left hand side dan right hand side untuk I, J, and K. So untuk I, this one kan, I, you have X, you have 1 over here, and you have 3. That's why you have X equal to 1 plus 3t. And for Y, for J, untuk coefficient for J, you have Y, you have 1 over here, and you have negative 1. So you have semua ni lah single 1 1 1. This is parametric. Then after you obtain your parametric, then only you can obtain your Cartesian. So when you have point, dekat sini extra sikit lah question dia sebab dia ada mention about a point. There is a point there, point A. So this point A, you can actually write it down in terms of 7 because this is I, this is J, and this is K, right? So you can equating this I berkali atau coefficient untuk I ni adalah 7. So 7 equal to 1 minus 3t. Okay. And the second one is like that and the third one like that. Okay. Dia guna yang ni. Ini 7 dapat dekat sini. And negative 1 dapat dekat sini. And this one dapat dekat sini. Okay. So, yang ini 1 minus 3t ni, dia compare dengan yang sebelah kanan. Sebutan untuk X. This one untuk sebutan untuk X. This, sorry. Not X. I'm sorry. Untuk I. This one untuk I. This one untuk J. This one untuk K. Okay. So, you comparekan kiri dan kanan. Okay, then you have T. Okay, dari sini you dah dapat parametric equation. You obtain lah T. You punya T. Macam mana obtain T tadi? Susun semula. Susun semula. This T bawa ke sini. Pindah-pindahkan dia lah until you get this T. So now you get T equal to negative 2, and negative 2. Sama lah. So originally you have this one kan? Yang atas ni, ini original yang you dapat dekat atas ni, this one. So dia kata bila you dah ada yang ini, why don't you substitute the value of t equal to negative 2? Ganti masuk dia ke dalam negative 2. Kenapa kalau you perasan, kenapa kita dapat semua 2 dia, dia punya t equal. All the t equals are equals. Negative 2, negative 2, negative 2. It's because the point is actually on that line. Dia on that line. Okay? Berada di atas garis tu. So, of course, the t is the same. You substituting the t equal to negative 2 into the equation line. So, ganti masuk t ni sebagai negative 2. So, you get this one. R equal to 7i minus j plus k. So, A lies on L. Kita boleh kata A ni lies on L sebab semua dia punya t sama. Okay? So, that's it. That's how you show that the point A is actually lie on this line. Okay, we finish about line. So, let's recall what we have covered in line. For line, you have 3 types of equation. The first one is vector equation. The second one is parametric equation. And the third one is Cartesian equations. Okay, so you have 3 equations. So, in order to obtain Cartesian equation, you have to first obtain your Cartesian lah. Parametric. Daripada parametric baru boleh cari Cartesian. Okay? Okay, now we move on to the second subtopic of this application of vectors, which is plan or satah lah. Okay, so it's a little bit extra from what we have learned before, which is line. Line is just satu garis lurus, and then plan is a satah lah. So satah, like you have a piece of paper. So that paper is actually your plan, satah. Okay, anything yang mendatar. Okay, and that one is your satah or your plan, like this one. Okay, so let's see it more clearly. This is a plan, the one in the rectangle shape. Okay, yang 4 segi ni adalah kita punya plan. So you have n, vector n is the normal. Normal actually dia berserenjang or perpendicular with the plan. So this is your n actually. Okay, so this is your n yang berserenjang tadi. Kalau plan kamu macam ni, mendatar, dia menegak. And AR is perpendicular to N. A to R. So this is A to R kan? This is A. This A to R perpendicular to N. Dia berserenjang pula dengan yang N ni. Kalau N tu tadi, maksudnya dia 90 degrees lah. Maksudnya dia 90 degrees ke sini. Okay? Perpendicular to N. So you have R equal to X, Y, Z. Moves any point in the plan. Okay, so you boleh pindah-pindahkan dekat mana lah. Okay, so this normal is actually represented by alpha I plus beta J plus gamma K. Okay, so this is normal. Okay, let's see more about plan. Okay, plan's equation criteria. Kita ada kriteria untuk plan, satah lah. Satu satah, a plan is best has normal vector, which is this one, AI plus BJ plus CK, and that is passes through the fixed point A. Okay, maksudnya dekat sini, satu satah you tu ada merupakan satu ruang yang mana ruang tu ada satu normal vector. Satu normal vector yang kita tengok tadi lah. Ada satu garis menegak dekat situ. Ada dia punya normal daripada that satah. Yang mana that it passes through the fixed point. Dia melalui satu fixed point A. Kalau in the previous case, kita ada satu point kat sini kan. Okay. Atau dia kata, a plan passes through 3 fixed points. It can be not necessarily it only passes through 1 point. It can also pass through 3 fixed points. Okay, boleh juga dia lalui 3 fixed point. A plan has 2 vectors. So dia ada 2 vectors. Okay, atau lah. That is the criteria of a plan. SATA. Okay. Okay, let's see. You have like this. Okay, you have R is your position vector R, which is equal to X, Y, and Z. And then you dot product N. Okay, your N is your normal just now, equal to A dot product N. So A is a position vector of A, and N is actually your normal vector. N is normal, okay? Normal vector. Normal vector. Okay, so this is how you write down a plan. Okay, to find the vector equation of a plan, untuk cari sama juga, untuk bukan saja untuk line, tapi untuk plan pun we can find the vector equation like we did just now. The vector equation, we need a given point on the plan, a vector normal to the plan. So you have one given point, you need at least one given point or vector normal. Okay, untuk cari dia punya vector equation. So ini yang perlu. Untuk cari vector equation, you need at least satu point, or any point lah, A ke P ke M ke, and you have a vector normal, which is N tadi. Okay, so this is Cartesian equation for a plan. From R dot N equal to A dot N. So we base on this one. For plan, this is the equation. So you have R ni adalah ni lah kan. R, this is your N, this is your A, and this is your N. Masing-masing adalah dekat dalam dia. Kalau untuk N normal ini, AI plus beta J plus Y, K. Kalau R, X, Y, and Z. Kalau A, X1, Y1, Z1, which is we don't know what is actually the value, kan? So what happen next is you kena apa ni? You kena kembangkan dia. So you have AX plus BY plus YZ equal to, you kembangkan yang sebelah sini. Kembangkan sebelah sini. AX, ini untuk sebutan I, this is untuk sebutan J, this is sebutan K. Okay? Tidak, you just letak, cari, kembangkan dia punya coefficient. The coefficient, this one is the coefficient. X kali A, AX. Y kali B, that's why you get beta Y. And then you get Z times gamma, that's why you get over here, YZ. Okay? So this is actually the coefficient on the left hand side. Okay. And yang ni pula coefficient untuk yang sebelah kanan. So you have, this is for I. How do I obtain AX1? Darablah X1 kali A. X1 kali A. That one you get this one. And then dekat sini you kali Y1 times with B. So you get this one. And then Z1 times Y. So you get this one. Because this is the dot product kan, macam you darab lah dot product. So you have all this. Now you equating this one on this left hand side, equating with P. Dekat situ. So this P is actually equal to this. Maksudnya yang sebelah sini, semua yang sebelah sini tadi, you jadikan dia sebagai P. Yang P yang inilah. Instead of tulis panjang-panjang, you just write it down as P. Okay. So this is vector equation of a plan. Kalau apa tu? Tadi previously we have learned about line. Kalau line, dia R equal to A plus T, V kan? Vector equation untuk line. This is vector equation untuk line. Vector equation for a line. Okay. But this one is vector equation for plane. Okay, what you have actually over here, the one you're equating with P is actually your Cartesian equation of a plane. So you have vector equation of a plane, which is this one, and the one that you have kembangkan, that you have expand, this one, and this one, the coefficient, then you equating it with P. This is actually the Cartesian equation of a plane. This is the one. Okay, so you have vector equation and Cartesian equation. Okay, let's see the first example for plane. Find the vector equations, the first one, and then second one, find the Cartesian equation for the plane that passes through point A and is perpendicular to the vector, this one. So what does it mean by perpendicular? Meaning that you have a plane like this. For example, you have a plane like this. So you have a perpendicular to a vector. Perpendicular mean normal lah kan, kita punya normal. So perpendicular to the vector, this one that passes through A. So maybe this A is actually somewhere around here lah kan. So this is actually your vector normal. So you have this one, the vector equation for plane. So kita letaklah ganti masuk dia. So you tengok, this one is actually N. This is your vector normal. And this is untuk A lah, point A, this one. Okay, so you have followed this vector equation for vector equation for plane. R dot N equal to A dot N. So R over here, just write it down R. If you want to write it down using xi plus yj plus zk, also can. And then you have N, your normal vector, equal to A. A is actually your point just now. You have this one, 1, 7, and 0. You have, this is A kan? Yang 1, 7, and 0. Kan tiada K dekat sini because this is I, this is J, this is K. The K is equal to 0, but that's why you don't have K over here. Okay, so you only have I plus 7, J. Okay, and then this is your N lah. This is your N. This is also your N. So what happen next is you're going to multiply this one. Dia punya coefficient. Di sini ada 1, di sini ada 2. So 1 times 2. Coefficient untuk I. This one is coefficient for J. 7 times negative 1. This is negative 1 lah kan. Plus, dekat belakang ni tidak ada sebab tiada 0 kan. Boleh juga kalau you nak tulis pun. This one is 0 times 3. 4K. This is plus 0K lah kan. Plus 0K. Sebab kosong K dia. So, no point pun. Kalau if you still want to write it down, it's okay. You can write it down. Kalau tidak tulis pun boleh. So, this one you can settle. Calculate this one, you get negative 5. Okay, so the vector equation for the plane is this right hand side equal to negative 5. You don't have to solve for this one. Just go through the right hand side. Cuma selesaikan sebelah kanan sahaja. On this side. Okay, yang sebelah sini jangan kacau. So you have this vector equation for the plane. Vector equation. And then the Cartesian equation will be Cartesian equation will be yang kita kesamakan dengan P tadi. So what you have is, you have 2x, this is for x, right? 2x minus y plus 3z equal to negative 5. Dari mana datangnya yang ini? Yang ini daripada sini. Okay? 2 ini x kan? Ini x, ini x, y, and z. Ambil dia punya perkali, dia punya coefficient saja. 2x minus y plus 3z. Okay? That's why you got this one. So that's it. The vector equation and Cartesian equation. So senang saja. Untuk plan, you just have two equation, which is the very basic one is the vector equation for plan, which is this one, r dot n equal to a dot n, and the Cartesian equation, which is you equal it to p. This is your p lah. Okay, 5 ni actually your p. Okay, I think tengok dia compare. 2 ni dapat dekat sini, 2x, and the negative y dapat dekat sini. Kenapa negatif y? Sebab ada satu saja. Negatif 1j kan? So ada negatif y lah. 3 dapat dekat sini. It's just that you don't write down into using I, j, and k. I, j, and k itu adalah vector. You want it to write it down in the equation form. So kalau dalam bentuk equation, dia ada x, y, and z. Okay? Instead of using I, j, and k. J and k itu untuk vector. Okay? So that's it, all for plan and this whole chapters, which is application of vector. So we have covered the two major subtopics, which is line and also plan. And again, I recall in line you have three types of equation. The very basic one, or the first one, will be the vector equation. The second one is parametric. The first one just now, R vector equation is actually R equal to A plus TV. That one is for line. And then for parametric equation, you're going to equating, samakan sebelah kiri dan sebelah kanan, coefficient untuk I, j, and k. And then after you obtain the parametric equation, you can also obtain your Cartesian equation. So what is Cartesian equation? Cartesian equation is you are eliminating or you are removing, omitting, keluarkan you punya t. So t itu letak dekat luar lah. So you have that three equation for line. But for plan, you just have two equation, which is vector equation given by this r dot n equal to a dot n, where n is actually your vector normal vector, a is a position vector untuk point lah. Okay, and then you can obtain your Cartesian equation. Cartesian equation is you are equating it with p over here. P is actually you're going to have a value lah. Yeah, that's it for chapter application of vectors. Thank you. And please don't forget to subscribe my YouTube channel for more videos on mathematics. Thank you.